Chapter 16. Space, the Perception Deception. A boy was walking through the neighborhood with his dad when the man made a critical remark about some graffiti that had been painted on a wall across the road. The boy looked at the wall. "What graffiti?" he asked. "That graffiti," his dad said, pointing. "What are you talking about? There's nothing there." The man didn't find this game particularly funny. "What are you, blind?" As it turned out, the boy was colorblind. From the beginning of his life until that event, no one had known, because nobody had been able to look out through his eyes except him, and he had no idea that he was viewing the world differently from others. To be severely red-green colorblind is to stop at a road junction and watch the traffic light change from red to amber to red again, or from green to amber to green. Take your pick, because both colors look the same to a person experiencing color blindness. What does this weird mix of red and green look like? Brown? Not quite. To be red-green colorblind is to play a game of snooker and not be able to tell the red balls from the green ball. The brown ball is still brown. Actually, that's not quite right either. A colorblind person would see brown as something different from the way we see it. Colors are perceived by cone cells in the retina, which activate a pigment when they absorb light. A correctly functioning human eye has 3 such cones. With these, we perceive every possible color from black to white. A form of color blindness occurs when only 2 of the cones are functioning. This is similar in principle to computer printers that have separate cartridges for cyan, magenta, and yellow. If you've ever printed a page without realizing that one of your cartridges is faulty, the resulting image will look a little trippy. It's not just green grass or red lips that are affected, it's everything, because everything on the page is made up of combinations of just 3 colors. This will give you some idea of how the world looks to a colorblind person. Just bear in mind that it looks perfectly normal to him, because it's all he has ever known. Imagine red lipstick and green grass appearing to you as almost the same color. In the example of the graffiti, the wall must have been a particular shade of red brick and the paint a particular shade of green. A lucky balance on the color spectrum rendered the whole message invisible to the boy, while it stood out starkly to his father. Before you think, the poor guy never gets to see what the world really looks like, are you certain that what you're seeing is what it really looks like? Consider the bee. Its eyes are able to see ultraviolet light, which is invisible to humans. Flowers look vastly different to bees and other insects compared to how people perceive them. So never mind having a faulty human eye. Who sees the world as it truly is, the human or the bee? Or how about the bat? Bats have extremely poor eyesight and navigate by a form of radar called echolocation. Have you ever wondered what sort of picture of reality a bat has in its little brain? Something quite different from what we humans have, and yet I'm sure the bat feels it's seeing the world as it really is. In 1897, George Stratton, a psychologist from California, designed an experiment involving a pair of goggles that made the wearer see the world upside down. The goggles were worn all day, every day, for a period of several weeks. First of all, the observer had trouble coordinating himself, as you would expect. But after a period of time, an interesting effect occurred. He started to see the world the right way up again, while wearing the glasses. What really happened was that his mind had learned to adjust itself to the new way that the world was being presented to him. As a result of uninterrupted habit, the mind decided that this was how things should look. It got so comfortable with upside-down vision that upside-down vision became the norm. Even more interesting was what happened when the observer finally took the glasses off, returning his eyes to their normal operation. The whole world suddenly flipped upside down, and it stayed upside down until the brain went through yet another period of adjustment. Interestingly, our perceptions of the world around us are not fixed. When we deliberately distort those perceptions, our minds will grow accustomed to the new way of seeing the environment, and we will feel that it looks perfectly normal. Whether it's upside down or right side up matters not. Either way, it's just an interpretation. We can't get our hands on the actuality of the physical world. It's not even true to say that we see with our eyes. Light enters the eyes. It is then converted into electrical impulses and sent to an area at the very back of the brain called the visual cortex. It's here that we do our seeing, deep inside the darkness of our own skulls, which no actual light can penetrate. Light stopped being light the moment it struck the retina of the eye. None of us has ever actually seen light, strange as that sounds. What we see is a product of light, a second-hand pictorial representation inside our heads of a world outside our heads. But I have to wonder, since I can't reach the world beyond my eyes, what can I say with certainty about it? If I've never seen light, is light really light, or is it something else? If all I've got is the interpretation that my brain presents to me, what can I really say about the source? What can I say about the actuality of light? Nothing. Can I claim with certainty that the universe around me has any more substance than a dream? Of course, don't be silly, someone will say, slapping their hand against the table. Look, I can feel this. It's solid. It's real. But let's look closely. Do you really feel the table with your hand? Isn't it more true to say that your hand transmits a message to your brain via your nerves, and your brain then says to you, you felt that in your hand? Notice it's not your hand telling you that, it's your brain. The solid feel of the table is no more an indicator of the solidity of the world around you than what your eyes are telling you. All of the information your mind receives about the world comes second-hand via your senses. Therefore, there is no means of determining the essential nature of the source of that information. Shouldn't we just have a little faith, you might ask? It seems a bit obvious that the world is more than a dream. Well, this journey is all about questioning our assumptions. So before we jump hook, line, and sinker back into conditioned thinking, consider the following factors. Firstly, when we dream, we experience an interactive world of sight, hearing, smell, taste, and touch. For the duration of the dream, our consciousness is usually convinced that it is awake and experiencing the real world. Take note that during this experience, at no time do we see with an actual pair of eyes, hear with an actual pair of ears, or touch with actual skin. Certainly, the laws of physics in a dream world tend to be a little free and changeable, and in this respect, dreams and the external world are clearly different. The only point I'm making is that a real external world is not necessary in order to have a five-sense experience. You appear to be in a dream, but the dream is really in you. So, my question is this: is your physical body and the universe it inhabits truly physical in its fundamental nature? Or is physicality just a perception, as it is in dreams? We really have no way of knowing, since the answer lies on the other end of our perceptions. Our common sense tells us that the 5 distinct means we have of perceiving the world correspond to 5 separate aspects of the world: lights, sounds, scents, tastes, and material objects. But this is not the case at all. One of our senses is called touch, but all 5 senses are really variations of a single sense that can best be described as touch. When we smell, this is due to airborne particles touching our nostrils. When we see, this is due to particles of light, photons, traveling through space and touching our retinas. When we hear, it is because subtle movements of the air around us touch our eardrums. We exist in an arena of sense perception called the electromagnetic spectrum. Visible light, that which humans perceive, is only a tiny part of the whole spectrum. Adjacent to visible light on one side, we have ultraviolet light, then X-rays and gamma rays. On the other side of visible light, we have infrared light, microwaves and radio waves. When we look across the room, we see what appear to be solid objects and solid walls. But if our bodies possessed organs that could emit and perceive X-rays, we would be able to see or touch beyond the walls in a remarkable way. There would be little point in children playing hide and seek in such a world. We feel as if the radio waves around us don't exist until we switch on our radios and televisions, and a whole world of sound and vision suddenly springs to life out of thin air. We think of the objects around us as solid and impenetrable because our bodies, being made of the same kind of energy, cannot pass through them. But that doesn't deter radio waves, which will pass through the atoms of the walls of your house and touch the aerial on top of your radio. Your suitcase, as it passes through the X-ray scanner at the airport, is anything but solid on the monitor. Sound will pass through solid matter to an extent. Noisy neighbours, anyone? But when sound waves meet a vacuum, they stop as if striking a brick wall. This is why we have double glazed windows, 2 panes of glass separated by a slice of vacuum. Imagine a powerful sound wave travelling upwards through the atmosphere. As the air thins, the wave's progress is impeded until it finally reaches the vacuum of space and ceases altogether. To sound, a vacuum is an impenetrable barrier, whereas a solid wall merely dampens its progress. For visible light, the opposite holds true. Light travels through the vacuum of space unimpeded, whereas it stops dead when a physical object gets in its way. Taking this into account, we come to the remarkable understanding that what we call solidity is entirely relative. Matter is only solid in relation to a creature's optic nerve and the molecules of its body. Quantum physics has established that matter itself isn't truly made of particles, but waves, just like the electromagnetic spectrum. The famous double-slit experiment, pioneered in 1803 by Thomas Young, showed experimentally that photons behave like waves rather than particles. The experiment consisted of a device that would fire photons at a barrier. The barrier featured 2 thin vertical gaps side by side. Any photons that made it through the gaps would continue their journey. After a short distance, the finish line was a photographic plate that the photons would strike and leave their mark. Common sense dictated that when enough particles were fired, the image on the plate should have consisted of 2 parallel vertical lines. But in an act of extreme weirdness, the result was an interference pattern of many vertical lines, consistent with wave-like behavior, like the intersecting of 2 sets of ripples caused by 2 pebbles tossed into a pond. We could understand this if 2 distinct photons entered the slits at the same time, creating 2 separate waves that then interfered with each other. But the really mind-blowing aspect of this experiment was what happened when the photons were fired one at a time. According to Newtonian mechanics and plain old common sense, a single photon ought to pass through only one of the 2 slits, or none. When enough photons were fired, we should have ended up with 2 lines on the photographic plate, as some photons entered via the left slit, others entered via the right, and still others struck the barrier and stopped. But amazingly, we still ended up with an interference pattern of many lines, an interference pattern that gradually built up 1 photon at a time. If that doesn't strike you as utterly mind-boggling, then you're not thinking carefully about what the word interference means. 1 pebble dropped in a pond will create waves of perfect circles expanding from the center. There can't be interference in the waves unless there are 2 pebbles dropped. So how does 1 photon create interference? Each photon seemed to begin as a particle, become a wave of potentiality while traveling, turn into 2 waves that interfere after passing through the slits, then turn back into a single particle as it struck the plate. Whatever this implies about reality, it's clear that we are not living in a material world that consists only of Newtonian mechanics. The original experiment was concerned with light, but in 1999, a team of physicists in Austria replicated the experiment successfully using a series of football-shaped molecules made of carbon atoms. This is documented by Stephen Hawking and Leonard Mlodinow in The Grand Design, 2010. We now know conclusively that matter can and does behave in a manner that is supposed to be impossible according to Newton's laws. What exactly is the universe made of? At school, we are taught that atoms are like the Lego blocks of the universe, the fundamental units stacked together in three-dimensional space. Once you dig a little deeper, you discover that atoms are made of protons, neutrons, and electrons. Don't worry too much about what those are, other than tiny bits that make up the material universe. These bits actually constitute the minutest fraction of the atom itself. Atoms are more like tiny force fields than blocks. They mostly consist of empty space. This is what allows some parts of the electromagnetic spectrum to pass through solid matter. But keep digging, and the force field analogy doesn't hold true either, as quantum theory reveals electrons jumping around the universe in a manner that defies all common sense. Since I am not a physicist, nor do I even remotely comprehend the mathematics behind quantum theory, I will quote directly from those who know what they are talking about. Quote, "Quantum theory is perhaps the prime example of the infinitely esoteric becoming the profoundly useful. Esoteric because it describes a world in which a particle really can be in several places at once, and moves from one place to another by exploring the entire universe simultaneously. Useful because understanding the behavior of the smallest building blocks of the universe underpins our understanding of everything else." End quote. That's from the opening chapter of The Quantum Universe, 2011, by Brian Cox and Jeff Forshaw. If I called this subatomic teleportation, that doesn't come close to explaining the strange behavior of the electron. Einstein, who established that nothing can travel faster than the speed of light, called it spooky action at a distance. His context was the classical level of reality. But we know that the classical level is ultimately constructed from the fuzzier, weirder subatomic arena. The world you see with your eyes is not reality itself, but the product of a more fundamental reality that is almost incomprehensible to the mind, and I'm not sure I'm justified in including the word almost. The atomist philosophers of ancient Greece originally employed the term atom to represent the theoretical fundamental particles of reality. A in front of tom means non-divisible. But atoms, as it turned out, weren't so fundamental. Inside the atom we uncovered the electron, and the electron, instead of behaving like a nice tidy Lego block bound by the laws of physics, was simply going bananas. It was as if the universe said, "Aha, you thought you had me all figured out. Now watch this." Our failure to arrive at a complete and coherent classical view of the universe tells us that the universe's fundamental nature is not classical. It is non-local, not bound by the laws of space-time that apply to everyday objects. We needed a whole new theoretical science, along with strange terms like entanglement and superposition, just to deal with the misbehavior of the electron. A science so complicated that a popular saying, widely attributed to the physicist Richard Feynman, is, "If you think you understand quantum mechanics, you don't understand quantum mechanics." There are various competing quantum theories on offer, but what is certain is that common sense materialism no longer works. The entire universe is better modelled as a unified field, an interconnected unity where nothing is separate, including the fundamental particles. When a particle can exist in several places at once, that's telling us that the idea of a localized particle is an inadequate symbol for modelling reality. The universe seems to appear to us as particles when we're observing or measuring it, but when we're not looking, it behaves as waves. It's not as if the universe actually flips between two states depending upon observation. We simply need to differentiate between the appearance of reality and reality itself. Color, for instance, is an aspect of the appearance of reality, but any physicist will tell you that color is not real in nature. Nature contains frequency and wavelength. Color is only how those appear to human consciousness. The fact that we can observe fundamental particles and waves makes them both aspects of the appearance of reality. Wave and particle are both inadequate terms because they are symbolic representations of reality, not reality itself. That is why they appear to conflict. The term unified field is one that allows us to transcend the limitations of our current symbols. Unified field points to reality itself beyond appearances. Crucially, reality is never anything but a unified field, despite how it appears when measured by humans. Try to visualize an incomprehensible mass of interpenetrating waves. Within this sea of energy, some waves interfere with each other, creating patterns. The persistent illusion of seemingly solid matter is the pattern that arises in our experience. But let's ignore this mirage in an effort to get in touch with whatever else is going on. Try thinking of the world around you as invisible. See only the edges of objects and walls. Visualize the various electromagnetic waves flowing through the structure as an array of colors. This crude approximation is closer to the true essence of reality than the world in front of your eyes, which is really the world seen through a pinhole. It's hard for our common sense to embrace the idea that solidity isn't truly solid, regardless of what the science says, but modern video games provide a useful analogy to help us make the transition. In a game, we can take part in adventures across city-sized maps, with amazingly detailed roads, buildings, and countless nooks and crannies for exploration. We can make our game character turn his head in any direction and watch the real-world laws of geometry playing out in two-dimensional space on the flatness of our television screens, beaming out texture, light, and shadow. Once, while playing a video game, I had a moment of clarity. I was standing on a virtual hillside, gazing down through the trees at a lake and a castle on the opposite side. It was a picturesque scene, and in the real world, it might have made me reach for my camera. I thought, no one else has stood on this precise spot and looked down the hill at this exact angle, not even the game's creators. The game arena is just too vast. It struck me as profound that something so aesthetically pleasing, something that was just for me in this moment and no one else, could spring to life from nothing more than a rapid series of mathematical equations being processed inside my computer. In video games, we experience an interactive world of sight, sound, and touch, a limited but spectacularly detailed facsimile of the physical world. The big question then is this: since we are able to create this 3D experience inside a computer, should we assume that our universe is truly 3D in its deepest essence, in its actuality? The three-dimensionality of a video game is nothing more than a river of binary ones and zeros flowing through electrical circuits, and yet the laws of physics in a game are as solid and dependable as the laws of physics in the real world. Where does all the mathematics in a video game come from? It comes from observing the physical universe, understanding how it consists of geometry, light, and shadow, then recreating it elsewhere. Using today's powerful computers, the mathematical computations can be so extensive as to produce photorealism almost indistinguishable from the real world, such as the special effects in big-budget movies. The reason why we can create an approximation of the physical universe on a two-dimensional television screen using nothing more than mathematics is because the universe has no more actual substance than its mathematics. We are so used to thinking of atoms as the building blocks of reality, but in an even deeper sense, it's mathematics that's holding everything together, and the atoms are nothing more than bits of information being organized by mathematical principles. We tend to think of the physical world as being the fundamental reality, what's really real. But from a mathematical perspective, the world doesn't need actual solidity in order to be experienced. It only needs mathematical organization. Solidity is the interpretation that your consciousness places on the information it receives. But the universe is so big, you object. Well, when I hold a disc in my hand containing a video game that allows me to explore an entire city, does the magnitude of that city have any bearing whatsoever on the tiny object I'm holding? No. Likewise, the physical size of the universe has no bearing on its fundamental essence. A group of people can exist in various places across the world and can take part as players in a single three-dimensional video game arena via the internet. By the same principle, consciousness can experience the universe without the need for an actual physical universe in the classical sense. Life conditions us to automatically make the assumption that the mathematics is an expression of a fundamentally real physical world. But when you dig deep and really think about it, you realize it's the other way around. The apparent solidity of the world is an expression of the mathematics. Solid matter is only the mathematical organization of data. If you've never witnessed a hologram in real life, I recommend the experience. There are many cheap holograms on sale which feature only two flat levels of depth, one on top of the other. A proper hologram is a much more startling image to behold. I have one in my possession, a holographic photo of a panther facing the camera with its jaws open, presumably a stuffed panther. Some people have asked me, why do you have a black picture on your wall? The hologram is invisible in normal lighting conditions, but when you dim the lights and shine a light onto it at a certain angle, wham! The panther's snout is poking right out of the glass at you, while its forehead is somewhere inside the glass, fully 3D. You can even change the viewing angle of the photo and watch the head tilt slightly from left to right, allowing you to literally see around corners. If you look inside its mouth, you can peek behind its fangs to parts of the tongue that were previously hidden from view. It all looks completely solid to your mind, and yet it's not. Reach out and touch the end of its nose, and your finger passes through air. The appearance of three-dimensionality does not require actual three-dimensionality, and if we are able to demonstrate such a principle with our own human inventiveness, it should not be so great a leap to comprehend that the universe itself acts on a similar principle. When we gravitate towards our established understanding that the universe is solid, we're not necessarily gravitating to the truth, only to the familiar. And that familiarity is based on nothing more concrete than the assumptions of our heavily conditioned life. Someone may say, I switched on my camcorder, pressed record and left the room. When I came back and checked the tape, it had recorded the room successfully. Clearly the physical world exists apart from my perceptions of it, since I've managed to capture a part of it on video when I wasn't looking. This is a misunderstanding of the holographic perspective. All the mathematical computations that keep the universe running are quite real, including the computations of a holographic camera recording a holographic room. I once played a video game where one of my character's gadgets was a camera that I could stick to a wall, enabling me to wander elsewhere in the game arena and check on the camera remotely anytime I wished. Here is the same principle existing in a completely virtual world. In the real world, when you look at a recording, you are proving nothing about the nature of reality, because once again, you can only see the recording as a perception through your eyes and brain. To call the universe a hologram is not to make assumptions about it, but to strip the existing assumptions away, assumptions that have festered there simply by the conditioning of your life experience and education. It is to say, simply, that the universe is information. The universe, according to Newton, is officially dead. The realm of separate objects stacked in three-dimensional space is merely an appearance of a much deeper and stranger reality, where everything is interconnected as a unity. Some people simply will not enter into this manner of thinking because it seems repugnant that the universe should be telling us fibs about itself. But consider, we thought the earth was flat because that's how we saw it, but it was spherical. We thought the earth was stationary at the center of the universe because that's how we experienced it, but it was actually orbiting the sun. We thought space was fixed and absolute because that's how it appeared, but it was bent and warped. We thought time existed in discrete units because that's how we experienced it, but it was elastic. When a kitten sees its reflection in a mirror for the first time, it thinks it's looking at another kitten, one that mimics its every move. Its interpretation of the world is wrong until it eventually learns its mistake. We are no different. The key question is whether you want to trust your perceptions or try to see the bigger picture. To assert there is no deeper truth than what my eyes tell me is to lock yourself into the outdated classical paradigm. The universe lies until you figure out the lies. Its purpose is not to tell you its innermost secrets. Its purpose, at least in relation to creatures, is to facilitate conscious experience. It is up to us to probe its true nature.